guys, Mr. Gibson here. I'm going to show you guys how to identify key features of graphs. So let's go through a few of these key features here. The first one I want to talk about are intercepts. Intercepts are where the graph crosses the x or y axis. Okay, here's your x-axis, here's your y-axis. So I have a linear function right here, a linear graph. It crosses the y-axis right there, so we call that point right there the y-intercept. Similarly, x-axis, y-axis, I have a quadratic function right here. It makes this parabola shape, and it actually has two x-intercepts where it crosses the x-axis, okay? If I want to be real clever, I can identify this point right here as the y-intercept as well. Okay, next key feature is domain. Domain is all possible x values of a function, okay? In this case, we're talking about graphs. So a graph is one way to represent a function. The other two ways, of course, are tables and equations. But we're worried about graphs today, okay? So if I have this step function right here, this piecewise function, it starts, let's go left to right. It starts right here on the x domain right here, the x-axis starts right here, and it ends up right there, okay? It does this little step thing, but we're not too worried about that. So the domain would be from here to here. Those are all the possible x values that are in this graph, okay? Similarly, range. It's all possible y values of a function, or in this case, a graph or representation of a function. So we see here, this is our lowest value of y that's on this step graph. Here's our highest value of y, so the range is this right here. Better yet, let's look at an example. Here's our function, here's our graph right here. Domain starts right here at -3 and goes to 4. So I can express it like this, -3 to 4, or x is greater than or equal to -3 and less than or equal to 4. Range, well, the graph starts right here at -5 on the y-axis and ends up right here at 6. Okay, so we go from -5 to 6, or y is greater than -5 or less than 6. That's domain and range. This is our second key feature. Next key feature, I've kind of combined a few together. We're going to talk about intervals. Okay, intervals are just segments of the graph. All right, in the last examples that we had with domain and range, these would be your intervals. Okay, this is just your segment of the graph that we're looking at. Okay, increase and decrease. So the key here is, you guys, I'm sure you understand increase means goes up, decrease means go down, but the thing is you're going to have to read the graph from left to right, like you read a paragraph, okay? So let's look at this example here. So if I have this graph, if I start from the left and go right, well, from left to right, it's increasing to this point right here, then it's decreasing from left to right, and then it increases again, okay? So this is your interval of increase, interval of decrease, interval of increase, okay? Now it's a good time to point out another key feature, is maxima and minima, okay? Maxima means top of a hill, or the top. Minimum means the bottom, okay? Better yet, it's a point where a maximum would be a point where the graph stops increasing and starts decreasing. A minima is a point where it stops decreasing and starts increasing, okay? Sometimes they'll be called a relative maxima or minima. That means compared to everything else around it, it's a top. Or compared to everything else around it, it's a bottom, okay? So let's look at this example right here. Increasing, stops increasing right here, and it starts decreasing right here. So this is a maxima. It's a relative maxima because it's not the top of the graph. Up here, the graph keeps going up. It gets higher and higher. But right here, compared to everything else around it, it's a top. So it's a relative maxima. Decreases, then starts increasing right here at this point. That's a minima. Again, it's a relative minima because compared to everything else, it's the bottom, but it's not the bottom of this graph. It keeps going down, okay? Here's an example right here where we actually don't have a relative maxima, okay? It's what we'd call an absolute maxima, meaning that it's the only maximum is right here at this point 4, 5. Again, let's look at the graph left to right, increasing to 4, 5, decreasing this way, okay? So I've got that written right here. Increase, negative infinity, so from the right to 4, and then it decreases from 4 on out to positive infinity. that's going to help us with the next thing that we call end behavior, where the graph, quote, I say ends up. All right? So follow along here. What we say is this. So I have a nice exponential function right here for you guys to look at. All right? And what I'm going to say is x, what this arrow means, approaches or goes to positive infinity. So as x goes to positive infinity, that means we're going to the right. Okay? As the graph goes to the right, as we keep going to the right on the x-axis. Okay? What happens to the graph? Well, if I look right here, as we go to the right, the graph just keeps going up forever. Okay? So that's what this means. This f of x symbol, function notation, which we'll talk about later, means the graph goes to or approaches infinity. Okay? Positive infinity. So it goes towards up. All right? If it were negative infinity, it means down, but in this case, it's going up, so it's towards positive infinity. Okay? Now, similarly, right here, I have x as it approaches negative infinity. So that means as we go to the left, because negative is left, right? So negative infinity, so that means as it goes out forever to the left, what happens? Well, if you see here, as it goes to the left, it gets closer and closer to 0. Okay, this x-axis, the y value of 0, and it never crosses 0. So we're going to say that the graph, or in this case the function notation right here for the function, the graph goes to 0. So as it goes to the left, it goes towards 0. Okay? Thanks for your attention.